Hello there, and today I'm going to be going through a moments past exam question. Now this question can be found on the Edexcel June 2010 paper, and it's question 4. Now the first thing I noticed about this question was that there's a lot of information, but unlike a lot of moments questions, there's no diagram. So what I'm going to do is I'm going to read through the question and slowly draw the appropriate diagram for the question itself. So it says a beam has length 6 meters and 200 newtons. So I'm going to draw my beam, and I would recommend that you always do the same as well. So I'm going to draw my beam, and this is going from A on the left hand side to B on the right hand side. And it says the weight is 200 newtons. Now if you read further on in the question, it says, by modelling the beam as a uniform rod. Now what that means is we're allowed to assume that the weight acts exactly in the middle of the beam. So the weight, which is going to be acting downwards, of 200 newtons, this is 3 meters from A and 3 meters from B. It's in the middle of the beam. Reading on, the beam rests in a horizontal position on two supports at points C and D, where AC is 1 meter and DB is 1 meter. So that means the distance from A to C is 1 meter. So I'm going to draw C underneath a little pivot, and that's 1 meter. And the distance from D to B is also 1 meter. So I'm going to draw another pivot towards the right hand side of the rod. Label this D, and again this is 1 meter. Next part of information: two children, Sophie and Tom, each of weight 500 newtons, stand on the beam, with Sophie standing twice as far from the end B as Tom is. So Sophie will be somewhere over here, and Tom is much closer because Sophie is twice as far. So if I draw an arrow down of 500 newtons, this can represent Tom, and twice as far from the end B, so roughly about here, is Sophie, and she also weighs 500 newtons. So I'm going to have that force acting down as well. Now we need some way of measuring these distances, so I'm just going to say the distance from Tom to B is equal to x, and the distance from Sophie to B will be twice this, so 2x. So I'm just going to put another arrow from Sophie to Tom. This distance here is also x, which means the total distance from Sophie to B is 2x. Now the beam remains in horizontal and in equilibrium, and the magnitude of the reaction at D is 3 times the magnitude of the reaction at C. So because this beam is resting on two supports C and D, there is going to be a reaction force pointing upwards. So at both D and C, I'm going to draw an arrow showing my reaction force. Now the magnitude of it at D is 3 times the reaction at C. So if I call my reaction at C equal to R, then my reaction at D will be equal to 3R, because it's 3 times as big. I've already used the fact the beam is a uniform rod by placing the weight in the centre of the beam, and I've also assumed that the children are modelled as particles, so that means that their weight acts in a single point on the beam. The question for 7 marks is asking us, how do we find how far Tom is standing from the end B? So in other words, we have to find this distance x. Now there's 2 things that we don't know in this diagram. We don't know the reaction force at each of C and D, and we don't know the value of x. Now it doesn't explicitly tell us to find the reaction force, but that is something we're going to need to find, so that when we take moments to find x, we're not having an equation depending on r. So to start with, what I'm going to do is I'm going to resolve vertically for the system. So I'm going to set forces pointing upwards equal to forces pointing downwards. Now when you do this, it makes it easier for the examiner to mark if you tell them what it is that you're doing. So something as simple as R with an arrow tells me I'm resolving vertically for the system. Now vertically upwards we have R at C and 3R at D. So the forces pointing upwards are R plus 3R. And because the system is in equilibrium, I can set this to the forces pointing downwards, which is the weights of Sophie and Tom and the weight of the beam. So that is equal to 500 newtons plus 200 plus 500. So that's Sophie, the beam and Tom. So this simplifies to 4R is 1200 newtons. Dividing by 4 tells me R is 300. So the reaction force at C is equal to 300 newtons. And the reaction force at D, which is 3R, 3 times the reaction at C, that will be equal to 900 newtons. So now we've found this, we can use these values in a moments equation to help find a distance x. Now because we want to find the distance x, which is the distance from B, I am going to take moments about B, which means I am going to look at all the forces acting in a clockwise direction, which are the reaction forces, and all the forces acting in an anti-clockwise direction, which is 500, 200 and 500. And because the beam is in equilibrium, I can set those equal to one another. And remember that for any moment, it's the magnitude of the force times the distance from where you're taking moments about. So, just like I made it clear to the examiner that I'm resolving vertically, I'm going to make it clear to the examiner that I am taking moments, excuse the bad handwriting, at B. Now looking at that, we have 3R, which is now we know is equal to 900, and we have R, which equals 300. So I'm going to do 900 times my distance of 1 meter, and I'm going to add 300 times my distance of 5 meters. So the clockwise moments are 900 times 1, adding 300 times 5. And I'm going to set these equal to the anti-clockwise moments. Now the anti-clockwise moments, that's going to be Tom acting at a distance of x, so that's going to be 500x. On top of this, I am going to add the weight of the beam, which is 200 newtons, acting at a distance of 3 meters from B. So that's going to be 200 times 3. And then I'm going to also include the weight of Sophie, which is 500 newtons, acting at a distance of 2x from B. So that's going to be 500 times 2x. Now if we simplify this equation, it will bring me to 2,400 on the left hand side is equal to 1,500x plus 600 on the right hand side. If I now bring the 600 over to the left hand side, then I'm going to get 1,800 equals 1,500x, and dividing both sides by 1,500 tells me that x is equal to 1.2 meters. So Tom is standing 1.2 meters from B. This distance x is 1.2 meters. Now in terms of where marks are allocated for this question, let me just get my red pen. You would get 1 method mark for each of these, for the idea of setting up 2 equations. So resolving vertically, just the idea of doing that gives you a method mark, and taking a moment gives you a method mark. Doing this accurately, resolving vertically, doing this accurately gives me another accuracy mark, and getting the correct moments equation gets me 2 accuracy marks. Now finally, knowing that I can substitute my values of R from the first equation into this equation and essentially solving, that gets me a method mark for using these values and an accuracy mark final answer, which gives me 7 marks in total.